Alright, topic 6.4 is called special segments in a circle. The first two examples are going to deal with two chords that intersect. And if you look at the theorem, it says if two chords intersect in a circle, then the products of the measures of the segments of the chords are equal. So that really tells you your formula. Product means you're multiplying, equal means you set them equal to each other. Now if you look at the little grouping symbol here, it tells us that this chord is 6 inches, but the markings here tell us that each pieces of that chord are the same. So let's go ahead and write in 3 inches, because half of 6 inches means each of those pieces are 3. Remember, product means you're multiplying, so it's going to be 3 times 3 has to equal the product of the other pieces of the other chord, the one that's going this way. So it's going to be 1.5 times x. This little piece, this is the x, the one we don't know. So that would make 9 is equal to 1.5x. You'll divide both sides by 1.5. 9 divided by 1.5 is 6. So that means the length of that part of that chord would be 6. It's actually labeled inches, so we'll go ahead and label that inches. So basically you're just you're just multiplying the two pieces of the chord. That's really what the theorem tells you. So look at example 2. This time the unknown, the measure, well, this one's asking for the measure of the radius, so we could either find the length of CE or ED, but let's figure out the missing part. So you know what, let's just put a little grouping symbol for this other piece of this chord CD. I'm going to call it X. And remember, the theorem tells us that we multiply the two parts of the chord. So 12 times X has to equal the product of the other two chords, 24 times 24. You just take the two pieces of the chords and multiply them together. So you get 12 times X is equal to 24 times 24 is 576. So then you'll divide each side by 12. When you divide 576 by 12, that equals 48. Now that's just the piece from C to this little part right here. So if we add 12 and 48, let me write the word diameter. The diameter is going to be taking that length and adding it with 12. So our diameter length, 48 plus 12, is 60 feet. But they want the radius, so the radius is always half. So the radius, I'll just write it like this, 60 divided by 2, so that's 30. So the radius is 30 feet. Just make sure you read your question carefully to know what you're looking for. Alright, we're going to get into secants, the secant segments for this picture. Let me move that up. For this picture, the secant, there's two of them. A secant, remember, is something that goes through and hits the circle twice. So SC is a segment that's a secant segment. The other one here is SA. Those are the two secants. Now there are external parts of the secant. This little line right here means this is the external. It's pointing to the external, and that just means on the part of the secant that's on the outside of the circle. So it's an external segment. We're going to use that word in a minute with the theorem. And this is another external part. I'm going to label the external part here is SE, and then the other external part or external segment is SN. So when they use that for the theorem, just make sure you understand that external means just the part of the secant that's on the outside of the circle. And we're going to use that theorem for example 3. So look at example 3. Now this is a really long theorem, but what it's telling you, let me move this down. This theorem is explaining what to do to find missing parts when you have a secant segment. Let's read it. If two secant segments are drawn to a circle from an exterior point, and in this case it's L, then the product of the measures of one secant segment and its external secant segment is equal to the product of the measures of the other secant segment and its external secant segment. So remember, on example 1 and 2 we just took the pieces of the chord and multiply them. Well, this one's a little bit different because you want to get the entire secant. Let's make a grouping symbol here. You might want to draw this on your paper too. The entire secant is LS. Well, the entire secant, if you want to figure out that length, you're going to have to add these two. So that makes that entire secant 26. On this entire secant, for OL, it's going to be x plus 6. That's the actual length. Since we don't know the length of OG, we're going to just say we're going to use the x. Remember, the word product means you're going to multiply. So you're going to take the entire secant and multiply it by the external part. See, the GL piece is the external part. Then you're going to take the entire secant of the other one and multiply it by the external part. So it really is just using these words. You're using the entire secant and then just the outside part of the secant. The only tricky part on this one, you will need to put the parentheses around the x plus 6, because to work this problem you're going to turn this into 6x plus 36. You'll distribute the 6, and 26 times 8 is 208. You move the 36, so you get 6x is equal to 172. You divide by 6, so x is... Now when you divide this one, it doesn't come out even. I'm going to show you on the calculator. When you take 172 and divide it by 6, see how you get, let me just show it to you, see how you get a repeating 6? That's kind of one you might want to memorize. 2/3 is a repeating 6. Even though the calculator rounds with the 7 on the end, it's still a repeating 6. So you could, if you wanted to write the decimal form, you could round it to 0.7, but I think I'll write it as the exact answer. It's 28 2/3. That's the length of OG, the part of the secant on the inside. Now there's another formula for when a tangent hits a secant. Look at example number 3. See, TR is a tangent line and SR is a secant line. So look at let's read the theorem. If a tangent segment and a secant segment are drawn to a circle from an external point, see how they meet at R, that's the external point, then the square of the measure of the tangent segment is equal to the product of the measures of the secant segment and its external secant segment. Let's write that a little bit easier. It's the tangent line squared. That's what the square of the measure of the tangent, that's what that means. And it's the product of the whole secant and the external segment of the secant. Okay, that might help you understand how we're going to set this one up. The tangent line is TR. So TR, since it's given as 12 as its distance, you're going to square the 12. The whole secant, in this case, they've already given it to you. See how they did the grouping symbol, and the entire secant is 16. And the external part is the one we don't know. That's the x. WR is the outside part of the secant. That's what's called the external part. So here's your formula. 12 squared is 144. 16 times x, divide both sides by 16. Your x would equal 144 divided by 16 is 9. So the length of that one would be 9. Come see me if you have some questions.